alaikum. Hello everyone. Today we'll talk about some of fitting methods in MATLAB. How can we use least squares curve fitting in MATLAB? We will use this command, least curve fit, this MATLAB command. But first of all, we want to generate a noisy data. This is our function, and we take x from 0 to 10 in step 0.1, and we want to generate a noisy data. This line of code, we add white Gaussian noise with SNR equal to 10, and this is the prototype of our function, which is here. All these A1, A2, A3, A4, A5 are factors we want to determine, and this is we put it in a vector A. So this is the prototype of our function, and we use the MATLAB command least square curve fit, LSQ curve fit. We put here our function, and we put the value of A, the predicted value of A. We put 1, 1, 1, 1. These are 5 values, and then we put our noisy data, which give us the real value of A. Then we plot the original signals and the fit and the signals with adding the white Gaussian noise to get this figure window. This is in blue the original signal, and the dotted line is the fitting, and the circles are the signal with white Gaussian noise. If we want to try this, okay. This figure window, what we get as we describe. Of course, this is one of the methods of least square fit, curve fitting. There is another method, fmin search. Here is the objective function, and x0 is the initial guess. Fmin search minimize the objective function, which we put here the error. We want to minimize the error, and x0 the predicted values of the factors. This we plot here the original data of the function, and here is the predicted value with the value of A. All the factors are 1. If we execute this, close this window, okay, this is the original function, and this the predicted value of the function. Here we write a function which give us the error E, and we put our data x, y, and the factors A, which give us the sum of the error squared, which evaluate here the function minus our data square, and we take all the sum, and which give us the sum of these squares. Now we want to minimize these errors by if-min search. We put here the function dataFit. This is the function dataFit, and here a, the predicted value of a, and our data, which give us the new coefficients, the new values of a. Finally, we plot all the figures, original signals and the fit, and the signals with white Gaussian noise. We'll try this. Here we get this figure window, the original signal in blue, and the dotted line is the fitting with if-min search, and the circles, the signal with white Gaussian noise. And here is the figure. Now we want to show how we use curve fitting toolbox to fit this equation. There is a curve fitting toolbox which fits curves and surfaces to data using regression, interpolation, and smoothing. We write this command cftool to cftool and this open this curve fitting tool. First we choose our data. X is the X data and Y is the noisy. We choose the noisy one, Y1. Okay, this is our data, and we choose here a custom equation. We want to write a custom equation, and I take this equation. We want to determine A, B, C, D, E. Okay, and we put it here in the equation section. Okay. This is the fitting, and the dotted here the data, our data, and here the new value of A, B, C, D, E, and which gives us also R square and RMSE. Now we want to see how we can make data prediction using neural network. By some lines of code we can use a neural network in MATLAB. First line, net equal fit net 5. 5 is the number of hidden layers. We choose 5. You can choose whatever you like, and you can optimize this number by choosing 10 hidden layers or less, and see what is the error. And you can also choose the layers transfer function. Here we choose sigmoid transfer function, transsig, and then the third row of this code, train. We want to train this neural network, testnet, by our data, noisy data. And finally, we predict the values of X. So Y predicted is the value of X, and we plot all the values. We take these lines of code and try it here. Uh, okay, and here is a figure. We can see the original data in blue and the net predicted values, which are good in my opinion with the original data, and the noisy data. Here is the noisy data. This is the result of neural network, and this is the neural network training tool. Here is the 5 hidden layers, and this is one input and this is one output. Of course, we can change the number of hidden layers and transfer function. Transfer functions are like this. We can choose the best transfer function to best fit our data. And here is the results of the figure we have shown. Okay, we see some of the fitting, curve fitting using MATLAB, some of methods. Thank you very much.